are right behind, I'm going to ask that you leave row D empty. Looking good. All right.
Yeah, nah.
Phones away.
All right, so I'm just going to see if we have anybody else joining us here. Oh, actually, no. I know you don't. You guys are getting a private show. All right. So if everybody's in, I'm going to close these doors and we can get started. What?
These are like 400 something.
Follow one of the lines and then
These are
follow
400 something.
up and then slow to you. It just looks like it keeps on going forever.
It does fit me.
Oh, my head.
I can't see the
Doesn't
top
fit you.
though.
You like it, bro? That barely fits. Oh my gosh, bro, my head.
Yeah.
But the planetarium, we were on the ground. Okay, but
I'll give these to
up, that's
Brianna
it.
for her birthday.
Oh, my head hurts.
I'm gonna buy Brianna a pair of Jordans for her birthday. What does she want?
Bro, this is like a scary roller
What type of shoes does
coaster.
she want? Huh? What color?
Exactly. Bro, these seats, there's nothing to protect us from
Put your phone
down.
away.
Huh?
Put your phone
They
away.
can't even protect us.
Put your phone away.
Yeah, but look how short that is. And look how straight this thing is, bro. My bro's scared. No, it's right there. Supposed to get up. Bro, why don't they let us record? It's so annoying. But just pay for this.
Put your phone away. No. I'm gonna call your supervisor. Phone away.
Yo, bro, my head. Bro, it's gonna be insane when this show starts. Bro, this is scary. It feels like you're on a roller coaster, right? Yo, guys,
Man change.
don't you feel like you're on a roller coaster?
Chris. Man change.
Bro, imagine we all fall.
Hold tight. Yo, come on, Tyler.
Bro, it feels like it's. Don't you feel like it's a roller
Okay.
coaster?
So sorry.
I feel like that we're gonna be moving.
So quick
I know.
before we get started, for the teachers, we had somebody who got a lunch delivery. What group? Your group number? One. I'm gonna put that lunch in your bin with group number 1. No problem. All right, perfect. Okay. So good morning, everybody. My name is Carrie. Up in the booth helping me out is Inez, and you guys
Yay.
are our first live program here in the planetarium since before COVID. So we're really excited to have you guys today. And you are also our first school group with our new projectors for a live program. So you guys are experiencing a lot of firsts here in our theater. Just a couple of things before we get started. Number 1, if you have anything that lights up, that is cell phones, smartwatches, light up shoes, I'm gonna need you to put them away, cover them up, or keep them as still as possible. Light of any kind is gonna light up your face and light up the screen. Plus, as it lights up your face, I know exactly who's doing it. So everybody will know who is interrupting our show. So please don't make me stop and ask you to put those things away. Keep all cell phones put away during the show. I'm going to ask Inez up at the booth there to change our lights to red. We're going to start getting your eyes dark adapted. Oh, we want red lights.
Yo, that's it. Nah, bro, this feels like the world is ending. That feels like hell. This feels like the world is ending, bro.
So we are starting to get your eyes adjusted to the dark. Who wants to raise your hand? Tell me how long you think it takes to get your eyes adjusted to the dark. What do you think? Across the way right there, your hand went up like first, before I even asked the question. Yeah. A little bit longer than a minute. What do we got? Shorter than 10 to 15 minutes. Across the way. Yeah, you. Yep. Longer than 3 minutes. All right, we're going to take one more all the way at the tippy top. Yep. Going to be 8 minutes.
Yes, I'm so smart.
Who knew it was 8 minutes?
Natalie's a bozo.
Yeah. Right? So it's going to take 8 minutes to get your eyes adjusted to the dark. It takes only seconds to unadjust them. That is why it is important that you keep anything that lights up put away. Now, during the show, it's a live program, so I'm going to ask you guys questions. I definitely want to hear your answers. But when you answer, the best way to answer is to say it once and say it loud. If you say it once and you say it loud, I'm more likely to hear you and hear a bunch of answers. If you keep yelling the answer over and over and over and over and over again, it turns into a whole mishmash of sound and I can't hear anything. So you're going to answer once, you're going to answer loud. Can you do that?
Yeah.
Close your eyes.
Want to try that again?
Close your eyes and you're going to see blue. Close your eyes and you're going to see blue.
Okay, so you guys got the loud part there, but remember, answer once, answer loud. That is the best way for us to hear what you are saying. And last but not least, at the end of the show, you are going to exit out of the top of the theater. You always go up the stairs, never come down the stairs, and you guys are going to remain seated for the duration of our show because it is dark and the stairs are steep. Are you guys ready?
Yes.
Are you excited?
Yes.
Are you awake?
No.
Yeah, some yes, some no's there. All right. So we are going to put something on the screen, get our lights off, and we are going to talk a little bit about solar systems.
Oh.
Hey. Hey.
Put my head.
Oh my god.
Looks good, right?
Oh my god. Oh my god. Oh my god. Stop.
So up there on the screen, we are looking at our solar system. What makes a solar system a solar system? Just think about it. What are some of the things that might make a solar system a solar system? What are some things that are in a solar system? How many stars are in a solar system? How many times can I say the word solar system? A lot. The answer's a lot. All right. So are you ready for your first question?
Yay.
How many stars are in our solar system?
No idea.
3. 3.
2
billion.
3.
Infinite. 3.
All right.
3.
So I've heard answers like 1 billion, infinity.
3.
I've heard 1. All right, so that's pretty much the biggest range we can go from 1 to infinity, right? One of those answers is correct. The answer is either 1 or infinity. So clap if you think the answer is 1. Okay.
Oh yeah.
All right, we're going to stop clapping. Clap if you think the answer is infinity.
Hell no.
All right, we're going to stop clapping for that. Clap if you clapped both times. That's typically the way it goes. All right, so infinity definitely had the louder applause, but The answer is 1.
Yeah, let's go.
Wow.
That's a bozo, son. For real.
I think all the other stars are.
There is 1 star in our solar system.
Sun.
You guys got it. It is the sun. All of these other stars, they're in our galaxy. They're just not in our solar system. So we can see them, but they are not in our solar system. And the sun here, is what makes the solar system. It keeps all of the objects out there orbiting around it. And everything that orbits around our home star, the sun, is in our solar system. Now, ours just happens to have 1 star. There are other solar systems out there that could have 2 stars at their center. They could have a binary star system, so that's 2 stars in the middle there. So when I say that a solar system has 1, I only mean ours. It depends on where you are, if you're in an exosystem. All right. What are some things that are in a solar system? We know we got a star. What else?
Asteroids.
Planets, yes. Planets for sure.
Asteroids.
Moons, yes.
Asteroids.
Asteroids.
Comet.
Yeah.
Humans.
The Kuiper Belt, yes. Humans, yes, that is very true.
The Eiffel Tower. The Eiffel Tower.
Possibly aliens.
The third June.
All right. So we got some good answers. You guys mentioned a lot of the things.
My
I heard
father.
asteroids. I heard the Kuiper Belt, which includes asteroids and comets. You said planets. You said moons. You included humans. Glad we made the cut. You said aliens, which I don't know. Maybe we're looking. So we are going to visit a lot of those things that you guys mentioned, but we are going to start by getting a closer look at our sun. So hold on to your seats, because Inez is going to fly us closer to the sun.
I swear that's
feel
not
like
me.
you're in a rocket.
I swear to God it's
Oh.
not me.
Yo.
Oh my God!
Yo.
Oh my God! Oh my God! Oh my God!
Yo. Yo, it's on us.
Oh my God!
Oh my God, look at my eyes! Yo!
So here we are at the sun. Our sun is pretty average. It's average size, it's average temperature, it's in the middle of its life cycle. Everything about our sun is average. There are plenty of stars out there that are much, much bigger. When you look at our sun, you can see the sunspots on the surface. Those are cooler areas on the surface of the sun. It shoots off solar winds from the sun. So the sun doesn't just sit out there. It shoots these intense radiation winds off of the surface of the sun that can affect other objects in space. We'll take a look at one of those later on. It varies in temperature. The sun isn't just one big ball of gas. There are a few different layers to the sun, and it combines hydrogen to form helium. And as that happens, that's what creates the energy of the sun. And that works from the inside of the core of the sun, which is much, much hotter than the surface of the sun. My mic went out for a sec. The surface of the sun is only about 10,000 degrees Fahrenheit. Chilly compared to the 29 million of the inside, the core of it. So that is what's keeping us all in place. Without the sun, everything in our solar system would float out into space untethered. It is the gravity of the sun that keeps everything moving around. Everything in space has gravity, and everything in space has angular momentum. Who's ever heard that word, angular momentum? Oh, a bunch of you have. What does it mean? Anyone want to tell me what it means?
No.
All right, I see it, right? What do you got? Right, momentum is an energy, it's a movement, right? And angular is a circular movement. So angular is circular, Momentum is movement, so it is a circular movement. That is why everything in space rotates and orbits. So anything that is in space spins and spins and spins. Okay, we're gonna visit all of our planets in our solar system. We're gonna head off to the first planet in our solar system. What's it called?
Mars.
Call it out. Mercury! So we're gonna fly on out to Mercury.
Stop! You all are bozos! Bozos! It's an asteroid!
Bozos! Bozo! Oh, bozo.
You know, you guys yell like you think Inez isn't a good driver. You're gonna give her a complex. She's an excellent driver. She's not gonna crash. All right, here we are at Mercury. Who can tell me something about Mercury? What do you know?
It's the closest planet to the
It is a planet. Great definition, because does it look like a planet when we first fly up to it?
Yeah, I guess.
It kind of looks like the moon, right?
Yeah. It looks like an asteroid.
Not the moon.
It is. All right, it is closest to the sun. Who else has something for me?
It's the second hottest. There's cheese on it.
It's the second hottest.
There's cheese
All the way
on
up
the
at the top. Just call it out.
There's cheese on the moon.
Yeah.
Venus is so warm because it has clouds that trap the
Oh, I didn't ask for Venus facts yet. We'll get there. I asked for Mercury facts.
There's cheese.
Size-wise.
It's blue.
Does anybody know anything about its size? Call it out. Yeah. All right. So you guys have mentioned a lot of great things. It is the second hottest planet in our solar system, and that's because Mercury is both equal parts really, really hot and really, really cold. When the sun is shining on it, it gets all of the heat from the sun, and it is close to the sun. But as it rotates on its axis and turns away from the sun, all of that heat just dissipates back out into space because there is no atmosphere to hold that heat down. So while it is over 250 degrees Fahrenheit on the sunny side, it is negative 250 degrees Fahrenheit on the nighttime side. So it has a huge temperature swing. It is our smallest planet, but it is incredibly dense and has intense gravity. If you have a smartwatch, I need you to cover that up because I can see that light. Thank you so much. So it's a very dense planet. It has a huge core on the inside, and it has one of the biggest craters in our solar system. So we're going to go take a look at the Caloris Basin. It's a huge crater
Oh my god!
on the surface.
Oh yeah!
All right, we can stop time right here, if you would please, and just zoom out a little bit. All right, we're looking for a crater, a really large crater. Let's stop right there. So, all right, I'm going to point out some craters. Clap if you think that's the Caloris Basin. I didn't even point anything out yet. You can't clap if I haven't pointed anything out yet.
Stop bullying
All right, I got to wait till you stop.
You're bullying. He's a bully.
Ready?
Cyber bully.
Okay. Is this it?
Yeah.
All right.
That's my son.
Okay, let's go. Is this it? All right.
Oh yeah.
Is this one it? No. How about up top here? Who thinks it's this one? All right, so all of you are saying this is the Caloris Basin.
Yes.
What have I told you?
No.
All of this is the Caloris Basin.
You're such a bully.
There should be such crazy applause going on in here for the Caloris Basin. This is the whole thing.
You're such a bully.
There you go. So every single crater I pointed out was inside of that giant crater. That crater's so big it takes up a huge portion of the planet. This planet, from, if you cut it in half, you put California on one side, New York on the other. It's the length of the United States. The Colores Basin is the size of Texas. So it's huge, it takes up a huge portion of that planet. All right, let's fly off to our next planet, Venus. And as we fly, tell me something about Venus.
Venus got a bigger penis.
It is. Venus is named after a Roman goddess, the Roman goddess of beauty.
Oh yeah.
Garrett, give me another fact.
Not a beauty.
It's the only reason it's warm because of clouds.
It is the hottest planet. What else?
Because the clouds trap.
Second closest to the sun.
It bullies me.
I think I heard somebody say something about Earth, compared it to Earth down there.
Bully.
Yo, stop. It
Yes.
feels like we're spinning.
So Venus is almost as big as Earth. It's so
Stop
close to
being
the size of Earth. It is known as Earth's twin. But I like to think of it as Earth's evil twin, because pretty much everything about Venus will kill you.
We're getting
I don't
so
know.
bullied right now.
Do you find...
That's Earth.
We're going to go over some facts about Venus, and then you can tell me if you think it's scary.
It's getting big.
So here we are. It's the hottest planet. It gets over 900 degrees Fahrenheit here on this planet. That is hot enough to cook a pizza in 16 seconds with no oven. Here, oh, that's a great question. We're going to get to that too. Here on this planet, those clouds, the atmosphere, is so thick that it traps all of that heat. So it has kind of the opposite issue that Mercury had. Mercury has no atmosphere. Venus has a ton of atmosphere. Those clouds also make the air, the very air around you, weigh 90 times that than here it is on Earth. So I want you to move your hands above your head. Just move one hand above your head. Is there anything there?
No.
Are you sure? Oh, I think I heard somebody say it. Right, there's air above you, right?
Oh.
All right, you can put your hands down. So we're surrounded by air. Even though we don't see it, we don't really feel it unless you can feel like the breeze moving past. There's always air around you. But we're really used to the weight of the air around us. On Venus, the very air weighs 90 times that. So just going to Venus can crush your bones. It's incredibly hot. The weight of the air will crush your bones, and it rains sulfuric acid.
Why didn't you tell me?
Sounds like a great place to go, right?
Yeah.
Yes!
Go.
So it is not a gas giant. This planet is a rocky planet because there is a hard surface. If we take down the atmosphere, those clouds of Venus, that is what the surface of Venus looks like.
Oh my God.
It looks kind of like Mars, right?
It's really big.
But it's really just all those thick clouds that give it this color.
It's really big.
All right. I need everyone to quiet down.
So big. Massive.
On the surface of Venus, forgot where we were, there are things called pancake volcanoes. We got a picture of some pancake volcanoes. No, I know who's going to put it up for us.
How dare you? Oh my God.
These are pancake volcanoes. This is an actual picture from Venus. Why do you think they're called pancake volcanoes?
I don't know.
They're shaped like a pancake.
Because what?
They're shaped like a pancake.
They are shaped like a pancake. And how are
No,
pancakes
they're
shaped?
not.
Circular.
Flat. You got it. Great question. How can we take a picture on Venus if you send a photographer? It could crush their bones. Because it also could crush metal, like crush a rover or a lander, because the pressure is so intense. So what they use are satellites. They don't actually land on the planet. They use satellites that go around the planet and take the picture through the clouds. So that was a great question. So this is a satellite picture of the surface of Venus. So flat volcanoes there on our closest twin out in space. All right, we're going to leave Venus and go to our next planet, which is Earth. So now everybody should be able to tell me something about Earth.
It's blue.
There are humans on it.
It's blue. It's blue.
There's water on it.
It's blue.
Call it out. What do you got?
It's blue.
It's only
There's water. It's in the Goldilocks zone. Good answer.
Bro, it's blue.
It has the Eiffel Tower.
Look at how beautiful it is.
My dad is in there. I haven't seen him.
Right there. I think
All
I
right.
saw my dad. Father, I see
So as we look, you guys gave all of the most important answers.
My father?
It has water on it from space. Our planet looks like this nice bright blue color. We are an ocean planet as well as a rocky planet.
Where's the dark water?
So most of our surface is covered in liquid water. That liquid water is very important for the other thing you mentioned, in that there is life on this planet. There are people, there are plants, there's animals, there's even little teeny tiny bacteria or little organisms that you can't see with your eyes. So we've got life, we've got water, and someone else mentioned that it is a Goldilocks planet. And so what that means is that our planet sits in the Goldilocks zone. So you guys know the story of Goldilocks, right? Oh, some people do, some people don't. Okay. So Goldilocks breaks into the three bears' house. And she starts to eat their porridge. There's 3 bowls on the table. And she tries
She's a bozo.
Papa Bear's porridge. And for those of you who know, Papa Bear's porridge is what? It's too hot. And then she tries Mama Bear's porridge, and Mama Bear's porridge is too cold. But then she tries Baby Bear's porridge, and it is
Just right.
just right. And that is Earth. We are just right for life.
Goldilocks
We are
is a
not
bozo.
so close to the sun that it's too hot. We're not so far away that it's too cold. Our atmosphere is not so thick that it's too hot. It's not so thin that it's too cold. We have a lot of things that are just right for life. One of the other things that helps life thrive here on this planet is known as the magnetosphere. And this is a force field that surrounds our planet.
Oh my god.
And then as you zoom out a little bit, you guys will be able to see it fully. This protects us. It's not the ozone. This is a magnetosphere. This is formed by our metallic core. It creates a magnetic force field that goes around our whole planet. Keep zooming out. Zoom all the way out till we can see the sun as well. Keep going. Because this magnetosphere helps keep us safe. Keep going, keep going. Keep going. All right, that's good.
Are we gonna die?
That's good right there. So the magnetosphere keeps us safe. I can tell by the shape of the magnetosphere that the sun is over here. If you go look to your right, the sun is going to be over here because I mentioned before at the sun that it has solar winds, this radiation that shoots off. As that solar wind shoots off into space, it blows back our magnetosphere. And all of that radiation hits into the magnetosphere, and most of it knocks off. So it hits into the magnetosphere and is deflected. So we have a magnetic force field around our planet. Sometimes it gets in. And you can see here at the poles of the planet, if those solar winds get in, mostly we get the beautiful auroras at the North Pole and the South Pole. So those beautiful lights that shine in the sky, that's what creates our auroras on our planet. So we've got a whole force field. All right. We are now going to our last rocky planet, which is Mars. Yeah. Mars has a nickname. What's Mars' nickname? The red planet. That is what it is known as. This is the planet that NASA hopes to send astronauts to. So that is their goal. They want to send astronauts to Mars because it is one of our close neighbors, right? On either side of us is Venus and Mars. Venus is deadly. Mars is a bit more friendly. It is pretty chilly, though, on Mars. A nice, warm, blazing hot day on Mars is only about 91 degrees. That's not too bad, right? We get those all the time. So that is really the hottest days you're gonna get here. Much cooler on Mars because we're getting further and further away from the sun. This planet is much smaller than Earth, so there's way less gravity. So when we send people here, they've got to be concerned about that. The other thing is that Mars has no magnetosphere. So when we send astronauts to this planet, they might be exposed to a lot of solar radiation. Now, NASA is sending things to Mars all the time in order to prepare for human travel. And the latest thing they sent was the Perseverance rover.
Oh, the person, yeah.
Yes. It is there studying the Jezero crater. So this is the rover. And Inez is going to take us to the location of the Jezero crater.
What's that?
It's about the size of an SUV, a small SUV. And they make them kind of look almost like animals. So like the head here that takes the pictures, that's like the head with the eyes. It will scoop up stuff and put it in a mouth and then send it through its digestive tract in order to study and analyze it. And then it shoots out like test tubes of samples that hopefully people will be there to be able to collect soon. So we've got the Perseverance rover at the Jezero crater, and we also sent Ingenuity, which is a rotocopter that we sent there. And it's the first time we have ever flown on another planet. So now we've flown on Earth and we've flown on Mars. It was a slightly longer flight than the first flight here on Earth, but the question was, could the rotocopter fly on Mars? Its air is thinner than ours, so the blades have to turn much faster in order to get up into the air. So we're going to take those two pictures down because we are sitting over the Jezero crater. And Inez is going to bring up for us a satellite picture of the Jezero crater. Right? This is the area we're looking at. Here's the Jezero crater. This is why NASA is looking at this area and considering it as the place to send people, because it looks like a place that used to have water. Whenever you see paths that are windy and twisty, like this right here, that's usually a sign of water. Water takes the path of least resistance, so it cuts through things in a windy way. It's not a straight line. And then it looks like water has wound through, like there was a river, and then emptied out into a basin, into some kind of greater area of water. So they think this used to be a lake that was all full of water. So they might find signs of extinct alien life, or maybe tiny little pieces of bacteria that are currently alive. You have a question? So they do think that, I don't know if everyone heard, did Mars used to look like Earth a couple million years ago? Scientists do think that Mars used to be covered with water, so that yes, it could have potentially looked like Earth in that it has a lot of water.
Could be lava.
All right, question. Yes, this is the part where, so they didn't find actual water here yet. They found signs that water used to be here. The poles are where you find a lot of frozen water at the moment. All right, one last question. Yeah, they do think that Mars did have a ton of water and probably more of the surface was covered. All right, I'll take one more question. Go for it. So they don't know if tardigrades, they haven't found, so tardigrades, the question was, do tardigrades live here on Mars? Tardigrades are little organisms, microscopic organisms that can survive in the craziest of situations. They're known as extremophiles. They have actually taken tardigrades from Earth, strapped them to the side of a rocket, shot them out into space, and not only did the tardigrades live, but they multiplied. You can freeze a tardigrade for 50 years and then unfreeze them and they come back to life. So tardigrades, these really hardy microorganisms out there on Earth, and they hope to find something like a tardigrade here on Mars, something that maybe is frozen in ice, maybe is really hardy, can live in extreme, harsh environments, and those are the kinds of aliens that scientists are looking for out there in space. All right, we're gonna keep cruising.
No.
And as we go out, we're gonna just look briefly at our solar system from afar, because there's something that sits in between Mars and Jupiter. You have a question, yes?
It's probably my.
Give me one.
Pluto.
Oh my God, what is it? Why don't you tell me?
Oh, good question. How long would it be possible for a person to live on Mars? It's a great question because we are trying to send people to Mars. Woo. And has brought us there to see how long can we live here. We're gonna go back out. So we'd have to bring some things with us to Mars. It doesn't have a thick atmosphere, so it doesn't have a water cycle on Mars anymore. So it doesn't rain, it doesn't have the same kind of water that we have. That would be a problem for people, right? We need water to survive. The oxygen is less than it is here on Earth. That's gonna be a problem for people. We need oxygen to survive. So if we bring things with us, we might be able to survive for quite some time because we bring some things with us. We build systems to create those things that we need there. We don't know. We don't know for sure. All right, so out here, when we are far out, in between Mars and Jupiter is a place called the asteroid belt.
Oh.
What do you think is in the asteroid belt?
It has asteroids.
Asteroids. Nailed it. Millions and millions of asteroids. They are all these weird, irregularly shaped rocks. They can be as small as a half mile, as long as 500 miles, but most of them are about as long as Long Island. They're about 100 miles in diameter. Most of them live here. They do live in other places, and they, just like everything else in our solar system, orbit around the sun. Sometimes they come very close to Earth, and they are called potentially hazardous asteroids. Recently, the mission DART, which is spelled with 2 A's, went out there to knock an asteroid off its path, because that's the big plan if an asteroid is coming towards Earth and we need to save ourselves, right? If we don't want to be like the dinosaurs, that they're going to send out a spaceship, knock it into the asteroid, and knock the asteroid off course. So they are actually testing that theory out at the moment. All right. Past the asteroid belt, which marks the midway point between our inner solar system and our outer solar system, is our first gas giant, which is what planet?
Jupiter.
Jupiter. Tell me something about Jupiter.
78 moons. 78 moons.
It has rings. It has lots of moons. It's the biggest planet in our solar system. Its gravity is so intense, it can cause asteroids to crash into it. You are correct. Or even sometimes comets. There is a great red spot. That is a big storm that is on the surface of Jupiter. For as long as people have been looking up at Jupiter, that storm has been there. So that has been going on for centuries, 400, 500 years. Okay. There it is, the big red spot. It's big, it's red, it's a spot. NASA is great at naming things. I don't know what to tell you. It is getting smaller, so it's gone from a big red spot now to kind of like a medium-sized orange dot. They sent a spacecraft called Juno out to study Jupiter. All of the things you mentioned are correct. It is the largest planet in our solar system and probably the first planet in our solar system. It's made up of hydrogen and helium. It's leftover bits of the sun, so it's made of the same gases. It is a gas giant. That means there is no hard surface to stand on. If you tried to land on Jupiter, once you got through the atmosphere, if you were not completely shredded by the intense winds on that planet, you would sink straight down through to the core of the planet. There is no solid surface. The spacecraft Juno took some pictures of Jupiter, and the pictures are really beautiful. I think we've got one or two there. And as if you could give us one of those pictures of Jupiter. And they almost look fake. Okay, so that's one of them. That is of the south pole of Jupiter. So that's all swirling gases out there on Jupiter. And this is another one.
Oh yeah.
Where it looks like water, right?
That's a bozo.
Yeah, or it looks like Starry Night. This is all gas. This is a real picture taken by the Juno satellite. So this is a real picture of swirling gases, not a painting. But it looks, sure looks like one. Yeah, so Jupiter is sometimes thought of as a failed star. If Jupiter would have gotten way, way, way bigger because of what it's made out of, because it's just gases, it could have ignited and become a star in its own right. One of its moons, Io, is where we're hoping to, sorry, not Io, Europa is where we're hoping to find aliens as well. So we're looking both at Mars and we're looking at Europa. So if you could fly us off to Europa real quick. No, not Europe, Europa.
Your daddy left you.
It's a moon of Jupiter's, and it is completely covered in ice. No, it is not bigger than Jupiter. None of the moons of Jupiter are bigger than Jupiter. So if we cut this in half, they think underneath the surface of all of this ice is going to be water, vast oceans. So underneath the thick layer of ice is all water.
That's what they think, though.
So if there is water underneath that surface, then there could be different kind of organisms like tardigrades, things that are called extremophiles, living in that water. Because as far as we know, you need water in order to find life. So water is the first thing we look for. All right, let's go off to our next planet. Saturn, yes. And Saturn is known for one major feature. What's its major feature? Rings, yes.
So we're just gonna leave that moon cut in half?
Yes, the rings. The rings around Saturn are made of all different kinds of rocks. It's basically like those asteroid belts, except around a planet. And Saturn is kind of the best example of a planet. So a planet either needs to do or be three things. Are you guys ready?
No.
I'm going to ask you guys some questions, so I need everyone nice and quiet listening up. Does Saturn orbit the sun?
No.
Yes, right? So all planets need to do or be three things. One of the things they need to do is orbit the sun. So Saturn orbits the sun. Another thing is that they need to be a specific shape. It is called an oblate spheroid, which means it's round, but it's kind of flat on the top and bottom. So, and then it bulges in the center. So oblate spheroid. Spheroid means sphere-ish. Anytime you see oid at the end of a sentence, it just at the end of a word, it just means ish. So it's sphere-ish. So is Saturn an oblate spheroid? Yes. Right? Is Saturn a planet? So the answer to all of these questions is going to be right. So it orbits the sun. It's an oblate spheroid. And does it clear its path, its orbital path around the sun? Yes, it does. And we know that because it has all of these rings. So all those little bits of rock go around it, and it has the most moons. Saturn has over 80 moons that go around it. So it has rings, it has moons, it's an oblate spheroid. It is the best example of what makes a planet a planet. Do you have a question? Saturn. So it's not the speed so much as the size. Because the bigger a planet is, the more gravitational pull it has. Everything has gravity, and the larger planets trap things around them a bit easier. All right, we are going to leave Saturn, and we are going to go off to our next planet, which is not. Oh yeah, it is. It is everybody's favorite planet to make fun of. Not Pluto. It is Uranus or Uranus. It's pronounced both ways.
Uranus.
All right, I need everybody nice and quiet, because I'm on a microphone and screaming. So here, this planet was almost called George.
I would like that a lot better.
George.
Uranus is better.
Which I think is a perfectly fine name for a planet, right? So the astronomer that discovered it, because this is the first planet discovered by a telescope, he was a proud British astronomer, and he wanted to name it after the King of England at the time, who was King George. So he wanted to call it George, Georgium Sidus, the Georgian star, all of those things. Other astronomers were like, definitely not. We're naming stuff after Greek and Roman gods and goddesses, like was mentioned before with Venus.
Uranus?
So this one was named because of its color. It's like this light sky blue color. So they named it after the Greek god of the sky, Urania, and that's how it got its name, Uranus, which everybody loves to laugh at now. Now this planet is different in that it lays down on its side. So all the other planets, your North Pole was here and your South Pole was here. On this planet, this is either our North and South Pole. So it's on its side. It got knocked into by something really, really big, really, really long ago, and now it lays down as it rotates on its side. It has rings. It has the second best rings in our solar system, and it is our first ice giant. We are now going to go visit our next ice giant,
Uranus number 2.
Neptune. Neptune is our last planet in our solar system. It is said that it gets so cold out here by Uranus and Neptune that you could stand on the clouds, which seems like the best reason to go out here. Please do not shout Uranus or Uranus repeatedly, because I can end the show and you guys can just go. Or just wait until it's time for your next classes. So here we are at Neptune. Neptune has these big spots that are storms that go all over the planet. It could rain diamonds here on Neptune, and the winds get over 750 miles per hour. So it has some of the most intense winds and the wildest weather in our solar system. It is so cold because we are so far away from the sun. The further you get from the sun, the colder and colder it gets. But is this our last object in our solar system? No, right? A few of you guys have mentioned Pluto. So, is Pluto a planet? No. And it is not a planet for one of the reasons that I mentioned before. I said it takes 3 things to be a planet. It needs to be an oblate spheroid, it needs to orbit the sun, and it needs to clear its path. So if we zoom out, I think we're heading over to Pluto. It's that third thing
Maybe I'll finally
that
find my
it does
dad.
not do. Pluto, when we get there, you'll see, is an oblate spheroid. It orbits the sun because it's in our solar system. But just like we have a Kuiper belt, asteroid belt, we have a Kuiper belt.
Jason.
And so Pluto orbits around with asteroids and comets far out here in space.
Father.
All of the planets you've been looking at today and dwarf planets that you are now seeing are covered in scientifically accurate maps. So these are pictures taken by different satellites that then cover our planets here in the planetarium. So it's like you are actually flying up and seeing them. So Pluto right? You can see it's that oblate spheroid shape. It orbits the sun, but because it's in the Kuiper belt, it doesn't kick everything out of its path. It is not a planet. It is a dwarf planet. We have 5 dwarf planets. 4 of them are in the Kuiper belt, and 1 is in the asteroid belt. Now, we're going to keep zooming out past to our Milky Way, because we looked at our solar system. But every single star you see has the potential to be its own solar system. So we are one solar system amongst billions of solar systems out there in our Milky Way galaxy. So we're going to keep flying out every single dot. They named it after this right here. Inez, can you fly? Oh, good. Sometimes it takes a little to see.
Yo, what type of card is that?
So they named it the Milky Way because they thought it looked like a white spilled spot across the sky. So they named it that just because they thought it looked like spilled milk.
What about the Milky Way
No.
candy?
So we're going to keep flying out of our Milky Way. So we're looking at our whole Milky Way. And as we do that, look at all of the dots that fly past you. Because every single one is a star. Every single one could be a solar system. Every single one has planets and asteroids and moons that are inside of it.
Oh, my eyes! My eyes. Is that the black hole?
No, that's
There is a black hole at the center.
That's our universe.
So that is our Milky Way. Now, we are one galaxy amongst billions of galaxies. So a bunch more dots are going to come up on the screen, and every single dot you see is going to be a galaxy.
Every galaxy equals a universe.
So just like ours is full of stars,
I don't see
all
that.
of these galaxies are also going to be full of stars.
Damn.
Every single dot that's coming up is also a galaxy.
Oh.
Bro, imagine being lost in the universe.
They're just too far away. I know, this took us really far out. Keep going in.
That's like Minecraft. That's the Minecraft road.
Keep going. Keep going in.
Minecraft universe.
Every single dot, all the pink dots, those yellow dots, every single dot keep going,
Oh my gosh.
is a galaxy.
This is the just Slither.io.
Every one of those boxes.
So all of this is in our universe. So there is a lot more solar systems to explore out there in space. And that doesn't just bring us to the end of our solar system tour, that brings us to the end or the edge of our universe. So we hope you guys had a great time here in the Cradle of in the Jet Blue Sky Theater Planetarium. You enjoy the rest of your day, and your educators are here at the top of the theater. So we're going to put on some red lights. We're going to get your eyes adjusted. And as you exit, please